Anybody know the definition of a function? Function. Anyone?
Function. Function is basically a rule.
Okay. What kind of rule?
Set of rules for
What set
Sir,
of rules?
if x and y are two non-negative sets and if we such a rule that if a unique y belongs capital Y or if x belongs capital X, then f is called a function from the set capital X to the set capital Y.
Okay. So from where
Google
did you
detected.
read this?
Google detected.
No. This is my hand note.
Okay. So can you tell me in simple words what is a function? Just in simple words. Or any daily life example, anything which can explain your definition.
It's something like a machine and
No,
it has some input and output.
No, I'm asking the guy who read the definition. Can you tell me in simple words? Whatever.
Two non-negative sets and f is such a rule there. Two
Right.
non-negative sets.
Can you repeat?
This is a two non-negative set.
No, I suppose that I know
Is an
not.
expression rule a law that
Wait.
defines a relationship between one variable to another variable?
Yeah.
Suppose I know nothing about f, I know nothing about x. I am a illiterate person standing in a market in front of any shop, and I am asking you, tell me the definition of a function. Now, can you tell me the definition without so many complicated words? Just a simple one line expression about function.
Can say, for example, we have a set of rules. For example, we have a machine and we give it our input.
Okay.
And the machine works on our input and modifies or changes it and then give us output.
Okay. Yeah. That's
so
fine.
That is a function.
That is fine. Very simple explanation of a function. In your home you have electricity. You have a fan. Now
I have good example. Like in daily life example. For you have a juice blender in your home.
Yeah.
You put input as a milk, apple, banana, and then you start it according to few words. It's a strategy after you get in the form of a milkshake.
Okay.
So it's a different output. So
Okay.
you can say it's a function.
That's it. So anything which receives some input and operates on it, do some work on it, and gives us some output is actually working on the basis of a function. Everything in your daily life, you can relate this definition of function. In your house, you have many examples. One example Josefa told us, um, grinding machine. Similarly, you have electricity fans in your house. Now you turn on the switch. When you turn it on, the input in the form of electricity goes into the fan, and the fan works on the basis of a function, a rule which is inside the fan, which is already defined, and in the consequence of that function, you receive the air and you do not feel hot. Everything is a function, is based on a function, but in mathematics, a function is a rule that assigns each value from the set of inputs a value in the set of outputs. We have a parabola function y equals to x square. So y is also known as f of x. If something is written as y equals to x square, you can also write it as f of x is equal to x square. Means these are the equivalent names of each other. Why I write f of x? Because I want to tell you that this guy is receiving some values and a function is operating on this guy, and as a result we receive the square of this guy. So any value, for example, if you have 1, now this is the set of input, and if in the set of input you have 3 values 1, 2, 3. Now you process this value 1 through the function f of x, and the function says whatever this value is, make the square of it. Now x means all those values which are in the set of input. I will pick these values one by one and process them through the function. The function is this guy. So when I will process this 1 through the function, and the function is this rule. The function is a rule, and the rule is written on the right side, that whatever the value you are taking from the input, pass this value through the function, and the function says yes, I will make it a square, and then on the right you will get the output, that is 1 square. Similarly, when you will process 2 from the function, the same function f of x equals to x square, on the right you will get 2 square. Similarly, on the right you will get a 3 square. So this is the simple definition of a function. You know this already from Advanced Mathematics 1. Now we have another thing linked with this definition, that is one-to-one function. Now sometimes there is a possibility that when you operate some value through a function, for example, I have two values, -1 and 1, and this is the set of input, and my function is the same, f of x equals to x square. Now the job says that I have to get some output for these inputs. When I will put -1 into the function, I will get 1. When I will put plus 1 into the function, I will get 1. It means that there were two inputs in the set of input, and when I process them through a function, this was the function. When I processed minus 1, it gave me this answer. When I processed plus 1, again it gave me the same answer. Now this is something further ahead of this definition of the function. You cannot say this is not a function. You cannot say that f of x equals to x square is not a function. No, this is a function because it follows the criteria of the function. It is continuous and it is taking some values from the input and giving us some output. But this function is not one-to-one function. So more precisely, the definition of function, we have now extended the version of the function to one-to-one function, and the one-to-one says that it is a rule that assigns each value from the set of input a unique value in the set of output, and it will never take the same value. If you have two values and you are telling me that the two values, say these are the two values, the first one is x1 and the second one is x2, and of course minus 1 is never equal to 1, so I'm saying that x1 is not equal to x2. According to the definition of one-to-one function, then the output on the x1 must not be equal to the output of x2. In this case, this rule fails. You see, x1 is not equal to x2, but f of x1 is equal to 1 is also equal to f of x2. When you process x1, you get 1. When you process x2, you get 2. Again, you get 1. So the output is same for both these input. Means x1 is not equal to x2, but f of x1 is equal to f of x2. If a function is following this criteria, then it is not a one-to-one function. A function is a one-to-one function that whenever you put two different values into the function, you get two different outputs. Is that clear?
Yes.
Now, the same thing which I have written here, we can define this thing graphically. Suppose the same function x square, and let us have another function x cube. And I already just now I proved that x square is not one-to-one. Because when you put minus 1 and plus 1, it gives you the same result. But this function is one-to-one. You can check. You can put any value and you will always get different result. For example, if you choose minus 1 and plus 1, when you will put the value into the function, for minus 1 you will get the answer minus 1. For plus 1 you will get the answer plus 1. So even the simplest case is not giving you the same value, and all others are also different. So this function follows the criteria. This is a one-to-one function, and the parabola is not a one-to. Now if I draw the graph of these two functions, you are very much familiar with the parabola. We have been dealing with this many times. This is the curve for the function y equals to x square, and this is the curve for which we have started the advanced mathematics 2 for the integrals, area under the curve stuff. Remember this portion?
Yes.
This guy is the basic of advanced mathematics too. We have started
Yeah.
our knowledge with this. So you are very much familiar with the graph of y equals to x square, which is the graph of a parabola, and the y equals to x cube, this guy has the graph like this, and here it goes up, here it goes down, they never come back. Now there is a word that is known as horizontal line test. One-to-one function is in the form of mathematics, this rule, and this rule is also called the horizontal line test. A function is one-to-one if when you draw a horizontal line in through the curve of the function, it never crosses the function more than one time. If the horizontal line passes through the curve of the function more than one times, then it is not a one-to-one function. If I draw a horizontal line for this function, for this curve, you can see there are many lines, horizontal lines, which you can draw, and they are passing two times through this curve, here and here, here and here, here and here, and so on. So there are infinitely many horizontal lines you can draw which are passing two times through this curve, and this curve fails the horizontal line test. Therefore this curve is not a one-to-one function. But in case of x cube, I told you this goes up and never comes back, this goes down and never comes back. So wherever you try to draw the horizontal line, the line above the x-axis, it will only cross one time through the function, only one point. So this guy passes this test. Therefore this function is one-to-one function, this is not a one-to-one function, right?
Yeah.
So actually in this chapter, this is the next chapter, and we are making the basics of some exponential functions, and then we will talk about the derivatives and integration of exponential functions, and also the inverse function. So this chapter, for me, I would like to complete today, but it depends on your understanding level. So maybe we may fail to complete it today, but I will try to finish it. And inverse of a function, so you already know that y equals to f of x is the definition of a function, and if you write f inverse of y equals to x, then this is called the inverse of a function, and we will try to learn how to find the inverse of a function. If we have some function f of x, we will do it. So if f is one-to-one function with some domain A and range B, then inverse of a function, f inverse, if the function is going from A to B, and this is, I'm saying this is the domain and this is the range, then inverse of this function f, which is f inverse, will be coming from B to A. So for this function, this becomes the domain and this guy becomes the range. Do you understand? If the function f has domain A and the set B is the range, then for the inverse function, this will become the domain and this will become the range. For example, you have function, the same function f of x equals to x square, and you have some data. For example, you have 1, 2, 3, 4, and you put them through the function, this function, and you have, so you are saying this is the input. When you put them into this function, you get the output. The outputs are like this. So this column is the set of input for the function f, and this column is the set of output for the function f. But when you will try to calculate the f inverse, then you will start from there and you will go to there. So you are, in case of in reverse, this is just a reverse order. In case of inverse function, this will be the input, and when you put this input into the inverse function of this whole function, the f inverse of this function f, when you put, for example, 1, you will get 1. When you will put 4, you will get 2. When you will put 9, you will get 3. So you can say the flip, you can flip the sets in case of the direct f of x and f inverse of x. And one thing you should keep in mind, that f inverse of x is not equal to 1 over f of x. Don't confuse yourself. This f inverse does not mean that the thing has negative power. Don't confuse yourself with this guy. If you have something like this, then it means there is something written inside the bracket and whose power is -1. So this guy you can write as 1 divided by f of x. For example, x raised to the power -1. So you can write it as 1 over x. But when you write f inverse of x, it means you are operating the inverse function on the x, and you cannot write it as like this. No, this is wrong. So don't confuse yourself in these two things. If you have any questions, you...
It means x by f.
It means
X by f. Because f inverse means 1 by f.
no, it does not mean 1 by f. I'm telling you that when you will write, when you are writing f inverse x, it does not mean that you are writing something raised to the power -1. So you are not allowed to write it as f1 over f of x. No, this is wrong, because this f inverse is not something raised to the power -1. This is a symbol used for f inverse. And you can also say that f inverse is a kind of a function, and you can give it a different name. For example, g. You can call f inverse as a function g. If you have function f, and this f of x is equal to y, and I am asking you to give me the f inverse, I can also ask you that give me an inverse function of f which is equal to g. So if I write f and g, and I tell you that f is the function and g is the inverse function of f, then it is not wrong. But you cannot say that f inverse is equal to 1 over f. No, this is wrong. It is not raised to the power -1. This is a symbol for the inverse function.
Okay, okay.
Suppose we have a function f of x and this function is equal to x cube plus 2, and I want to find the inverse of this function. So there are 3 steps. Step 1 is, or maybe sometime it is written, it is written in terms of f of x, and sometimes it is written in terms of y. So you know that f of x is the another name of y. This is very common and well known thing. So the step 1 is write this function in the form of y equals to x cube plus 2. This is step 1 for this function, and we are trying to find f inverse for this function. This is our job. Step 1, instead of f of x, put this whole thing equals to y. Step 2 is eliminate x in terms of y. So here you can see, you want to eliminate x, it means you can take the x cube on the right side and this will go here, so it becomes y minus 2. But I need x without any power, without any square root. Here it is x cube, so you can take 1 by 3 both sides. So it will becomes x equals to y minus 2 raised to the power 1 by 3. So I have got an expression in the form of x, in the form of y for x. So I have eliminated x from this whole expression. The third step is that replace x with y. Whatever you have got in equation 1, this equation, wherever there is y, replace it with x. Wherever there is x, replace it with y. So this equation will become, this is x, I am going to replace it with y, so this becomes y, and this equals to, on the right, this is y, so I will write it as x minus 2 raised to the power 1 by 3. This function is inverse function for this original function. So if f of x is x cube plus 2, then f inverse of x is x minus 2 raised to the power 1 by 3. So if you are given a function f of x, do these 3 steps and you will get the inverse function of the same function. Now what will happen? If you have a set of input, when you will put the values into this function, you will get some output. Now you have the output. Now put the output values into this function and you will switch back to the original input values. Do you understand?
Yeah.
Good. Now if we have function y equals to x square, then what will be the, this is f of x. Then what will be the inverse function for this? Can you help me to find? Very simple. Step 1, write it as y equals to x square. Step 2, eliminate x without any power. I have x square, so to eliminate x, I can take square root on both sides. So I will get x is equal to under the root y. Am I right?
Yes, yes.
And the step 3 is, wherever there is x, replace it with y. Wherever there is y, replace it with x. This is x, so it will be y. This is y, so it will be x. So it means this is the inverse function for this function. Now, you can check very easily for the same parabola function. I told you that if I have, for example, these 3 inputs, the outputs will be 1, 4, 9. Now when you put 1 into this function, you get 1, 2 gives you 4, 3 gives you 9. Now go back. You have this set, consider this is your input. Put 1 into this function, you will get 1. Put 4 into this function, you will get 2. Put 9 into this function, you will get 3. So, a reverse process. This is f from the set of A to B. Then f inverse gives you back the set A from B. And graphically, if you have something, for example, if we have a straight line, this is xy coordinate, and you know that the straight line y equals to x. This is a function, or f of x equals to x. This is a function which always gives you a straight line in the xy coordinate system. So if this is the straight line and I'm saying that I have a point somewhere here and I'm telling you this is a point AB, then and I want you to locate me the inverse point for this, then you simply need to flip these points. If you flip these points, in case of f inverse, this point is linked with f of x, and when you will find the f inverse will flip your points. So f inverse will give you BA, but what will be the position of BA? Means the B will become A and A will become B. But where it will be in the plane? Will it be on the same position or somewhere else? So it will be on the same distance. If this is distance D1 from the x-axis, then the flipping point BA will be on the same distance D. If this is D1, then it will be on the same distance from y-axis in the same plane. This distance, say this is D2, then D1 is equal to D2. Only the positions are flipped, and where these positions are flipped for this straight line. The positions are flipped around this straight line. So for example, if the function has a curve like this, then what will be the curve for the inverse function? This is the curve for the straight function f of x on this side from the x-axis. Then I told you the whole thing will be flipped, just like the wings of butterfly. So if you flip the whole thing to here, your curve will be like this. Understand? So you are flipping
Yes.
here to here. So your f is flipped into f inverse. If this is the shade for the f, then this is the shade for the f inverse. So they are flipped all the time. That is graphically whatever you do, whenever you draw the graph for the same function f of x and its inverse function, you will always see that they will flip. And if the function f originally is continuous, you know what is continuity, then f inverse is also continuous. And if the function f is continuous and one-to-one, then f inverse is also continuous and one-to-one. So their properties will not change, their orientation will change. They will flip to the other side of the butterfly, but their properties will be the same, the wings of the butterfly. Now, a very famous name, and that name is exponential function. Can you tell me what is an exponential function? Anybody? Whatever is in your mind.
Which which increases or decreases or change behavior exponentially.
Okay, good.
Gradually. Yeah.
Anybody else? So why it increases or decreases exponentially? What is special in this function that it increases drastically or decreases drastically? Any idea? You know, in simple functions, for example, the same. Since we have started this chapter with parabola, so let's talk about the same parabola. So in parabola, we have the function x raised to the power 2. So we always know that x is a variable, and this guy, the power in the power, is a constant, a real number. So the basic definition of an exponential function is any function in the form that some real number is taking the power of a variable. is called an exponential function. This b, any real number, and this b is taking a power, and the power is not a constant number, it is a variable. In the very simple function, this guy, so you can write this thing as x raised to the power b here in the case of parabola, and you say that yeah, where b is equal to 2, so it becomes a parabola. When f of x is x raised to the power b, and you are telling me that b is equal to 2, then it means you are talking about the parabola function. And in this case, you see the variable is on the base, and it is taking a power which is a constant number, and you can define the constant number. Here the case is reversed. Any constant number or any real number, whether it is rational, irrational, it is taking a power x, and x is variable. Then it is called an exponential function. And since the things are reversed, that is why, as compared to the polynomials, that is why an exponential function jumps or falls down drastically. Now, if you replace this x with the number n, any constant number, then what does it mean? You know that b raised to the power n. How to write b raised to the power n? How to write b raised to the power 3 in the form of factors?
b into b into b
into b. So if I have b raised to the power n,
number,
it means b is multiplied n times.
n number, yeah.
So b raised to the power n can be written as b is multiplied n times. But now, and in this case, I know that if n is some rational number or something
No,
like that.
because the exponent is variable, varies, that's why
Yes,
increases or decreases drastically.
So whenever some constant number has some variable, this variable is the culprit. I told you, I am from the day one, I am telling you that f is a simple guy, but the boy sitting inside is the culprit. F is one time rule. One time somebody defined that the fan will work like this in the clockwise direction. So function is defined, it is constant, but the input depends. Now if you change the voltage, if you change the power of the current, if you give them high voltage, maybe the same fan will burst. If you give them low voltage, maybe it will not work. So the simple guy is standing there. It needs the value of the variable to be a number. When you give this, replace this whole scenario, and you make it like this, that the constant number is sitting on the base, but the upper guy is changing all the time changing. This creates the problem. So that is why any exponential function is drastically increasing or decreasing, and the best of the exponential functions is always the e raised to the power x, and we will see why it is best out of all the exponential functions. In general, in your mind, you always have the idea, whenever somebody is talking about exponential function, you always think about e raised to the power x, right? Yes or no?
Yes.
We always think about e raised to the power x, or we always think about exponential of something, right? So in our mind, we always get this idea, but this is not true. Actually, any number raised to the power variable is exponential, but out of all those infinitely many exponential numbers, this is the best exponential number. That is why we always consider this guy, and we will see why this is best.
How this is the best?
We will see. I told you, we will see today why it is best out of these guys in the coming. So anyways, now suppose, assume that Yeah, I told you that if x is equal to some n, then b raised to the power n is simply b times the multiplication of n. So this is simple. But if x is some irrational number, in that case you say that the exponential number b raised to the power x, this is equal to limit r approaching x, b raised to the power r, where this r is some rational number. Because why we are talking about the rational and irrational? What is an irrational number? An irrational number is the number that when you do the place the point of the decimal, you start with, let's suppose, 0, and it never finishes 0, 1, 2, 3, 9, 5, 6, and it goes on like the number pi. After the point, it never finishes, it never stops. So this kind of a number is called irrational. So if we have a rational n, then no problem, you can simply define any value for the x and you can solve it. But if you have an irrational number, then there comes the concept of limit again, and I'll tell you how it appears. The concept of limit, you assume that there is a number which is a rational number, and this rational number is the for example, this guy sitting, this is an irrational number, and I'm trying to approach this guy from this side, and I'm very before this number, and I'm saying, yes, I have found a number r which is very much before this number, that in between these two numbers there is no other real number, which is practically not possible, but I assume in the case of limit, and I say, yes, if I approach this irrational number from a rational number, then I can say, yes, they are almost giving us the exponential function. Now let us take very simple example that how this limit is working. In case of rational, you can place x any value n, and that's done. Suppose we have under the root 3. So whenever you take under root, square root, this becomes an irrational number. But I know that square root 3 is, can you calculate the square root 3 on calculator? What is the answer?
0.7320.
The calculator, a good calculator, will never give you a perfect answer. It will give you some closing answer, but the answer always continues for the any value of square root 3. So in this case, I am assuming, but you can see on the calculator, the value is something 1.7 blah blah blah, right?
Yeah.
So I am assuming that suppose the value of this guy is in between 1.7 and 1.8. Am I right? Can I assume this?
Yeah.
So if I assume this, or if you go to further much closer approximation and you assume that, yes, the value of this guy is somewhere in between 7.3205 and it is under the root 3 and it is 7.73206. So I only left this margin. Now I'm trying to go closer. So this one was a very much big difference, delta x. This delta was almost 0.1. Now this delta is very much small. This is 0.0001. So I have taken a very small delta. So if I assume this is made much better. You can assume this. You can assume the next value, any value. You can go any further. But suppose this is the good point for us. And I'm assuming that, yes, the value of under root 3 is in between these two guys. Now, if I take them like this, if you have x and you take it as 2 raised to the power x, so if you do the same on the left and right, you can do anything on the left and right of an equation or equality, but you should do all the sides. You should do it all the sides. So I'm taking all these guys as the powers of 2. So I'm taking it as 1.73205 as the power of 2, and I'm saying this is less than 2 raised to the power of under the root 3, and this is less than 2 raised to the power of 1.73206. Can I do this?
Yes.
Can I do these two steps? I have done nothing
Yes.
strange. Whatever I have done on the left, I have done it on the right. So you are always,
No effect.
yes, so they both are equal. Now this is what, if you compare it with b raised to the power x, then I'm saying that b is 2 and my x is under root 3, which is an irrational number, right?
Yeah.
So this guy is an exponential function, but the raised to the power x is not n. In the first case, I told you if n is rational number, no problem, you can take any n from 0 to negative infinity or to positive infinity. But if this is this is not the rational number, if this is something like this, or if this number is under the root 3, or if this number is pi, you know the value of pi, and it never finishes. Something like this goes on. So this is also an irrational number. Now this number is exactly an expression in this form, but some constant 2, the base is okay, the same base, but the power is under the root 3. But on the left, this is again an exponential function. This is a kind of 2 power x, but the x is now a rational number, 1.73205. It finishes here, right?
Yeah.
So this is a rational number. Similarly, on the right, this is 2 power x, but the x is 1 point equal to 1.73206. Again, this is a fixed number, finishes here, so this is a rational number.
Yes.
So on the left and on the right, I have 2 raised to the power rationals, but in the middle, I have 2 raised to the power irrational. Now what is happening? The thing is that if I take these two, in the 3 inequalities, you can always compare 2 of them. So if I take these 2 from the left side, it means I'm considering 2 raised to the power r, which is a rational number. This is less than 2 raised to the power x. The x is what? X is under root 3, which is irrational, and r is this number 1.73205, and this is rational. Now I am assuming that when I cross this number on the real line, I get this number. So I am saying that this number r, it is almost approaching the number x. I am saying that from the left, my limit of number r is almost approaching the number x. Do you understand this? This is r, this is x, and I am going from the left to right. Suppose the numbers are located here. The middle guy is sitting here, and this is 2 under the root 3. And from here to here, I am approaching with the value r is equal to the value on the left, 1.73205. And from this side, later I will approach with this value, 1.73206. First case is left hand limit. If I approach from the left side to this number, I am saying that this is a number and on the very left of this number, they are connected like this. They are in between, there is no real number, and on the very left of this number is another guy which is 2 raised to the power this number 1.73205. So I'm assuming that these two numbers are very much close, that in between them the difference x goes to 0. The in between them the delta x goes to 0. Remember, whatever you step have, all these steps are called delta x. And I am saying that I have found a number which is rational. This number is rational because 2 is a rational number, and rational number raised to the power are rational. This number will always give you another rational number. So this guy sitting on the left is a rational number. This guy sitting in the middle is an irrational number because the power is irrational. And this guy sitting on the right is again a rational number. So I am considering the first two. I am saying I have found a rational guy sitting very before the irrational guy, such that they are almost sitting on each other, which is practically not possible, but I have assumed that this delta x is so small that it looks like 0. Of course, when you have two real numbers, there is always a real number in between two real numbers. Whether it is a rational or irrational, all these numbers which lie down on the axis line, they are called the real numbers. So whether it is irrational, it is a real number, it is rational, it is a real number. All the numbers on the line from negative infinity to positive infinity, all these numbers are called real numbers. So the rule, there is a theorem, and the theorem says in between two real numbers there is always at least one real number. So it means you can never find two numbers which are exactly connected to each other and in between there is no real number. If there is any such case, that theorem fails, and you can never fail that theorem. But I am assuming that I have found two real numbers. One is this guy, another is this guy, and I'm saying that they are very much connected to each other, that they look like there is no real number in between them. You know that it is not possible practically, but you are assuming that in between them the difference is 0. In between them the delta x is almost 0. It means this number, if you are saying the difference is 0, then it means 1.73205, and the next number is 2 raised to the power under root 3. If there is no difference between these two numbers on the real line, it means because the base is same. So if the base is same and if they have the same power, then they can give you the same answer. For example, if you take 2 raised to the power 2, it gives you answer 4. And if you take 2 raised to the power 3, it gives you answer 8. So what happened? The base is same, but the powers are different. They can only give you the answer 4 if their powers are same. So the base is same. If I am saying that these two numbers are same, it means their powers are also same. But actually that is not possible. But I will say yes, 1.73205 is approximately equal to under the root 3. And this is only possible when I say that in between these two numbers, in between these two big numbers which are getting the power from there, the difference delta x is approximately equal to 0. There is no difference between them. And if this guy is approximately 0, it means your number r, which is this guy, is almost approaching the number x, which is this guy. So both are approaching each other. R is approaching from the left to the guy. X means they are almost equal. Then this number b raised to the power r, which is this number, is almost equal to the b raised to the power x, which is this number. Do you understand? Similarly,
Yes.
if we move from the right side, then that will be the concept of right hand limit. So if I take the right points, the points were, one was 2 raised to the power under the root 3 and it was less than 1.73206. 2 raised to the power there. So if you try to approach from the left to right, this, the first definition was that limit are approaching to x from the negative b raised to the power r is equal to b raised to the power x. Means b raised to the power r was 2 raised to the power 1.73205 and this is equal to 2 raised to the power under the root 3, and if they are equal, then it means the value of under the root 3 is 1.73205 approximately. And if you come from the right side to the left, then you will say limit r approaching to the x from the positive side, b raised to the power r is equal to b raised to the power x. What does that mean? B raised to the power r is the right guy, 2 raised to the power 1.73206 approximately equal to 2 raised to the power under the root 3. It means under the root 3 is approximately equal to 1.73206. So the more bigger value you will pick up this, the more closer value of under root 3 you will find. So if you go further, you can find a more accurate value for under root 3. Means when you go very much closer to 0 in case of the difference of the two numbers. Okay?
Yeah.
The rules are very simple in the exponential cases. In exponential function, if you have b raised to the power x plus y, you can write it as b raised to the power x, b raised to the power y. You know these basic rules from the basic classes. Similarly, if there is a difference, then it will become b raised to the power x divided by b raised to the power y. And if they are like this, then you can write them as b raised to the power xy. And if there are two real numbers multiplied together and they have the power x, then you can always write them as a raised to the power x, b raised to the power x. So these are the rules working in the exponential functions. And two very important rules you should keep in mind, that if the number b is greater than 1, keep this thing in mind that an exponential function, the base will always be greater than 0. It will never be less than 0 in the exponential function. So either it can be 0 point something or it can be 1 point something and so on. But it will never be a negative number. So if this number b is greater than 1, so that I told you that the base b, the b guy is always greater than 0. What are the possibilities? It means the b can be in between 0 and 1 and the b can be greater than 1. So two cases only possible. There is no possibility that b can be less than 0. This is not possible. So in these two possibilities, if I pick up the first possibility, that if b is any number greater than 1, 2, 3, 4, 5, 6, 7, then the limit x approaching infinity, b raised to the power x, the answer will be infinity always in the case of exponential functions. And the limit x approaching minus infinity, the answer will be 0. So up to most the function can give you the answer 0, and up to least and up to most the function will give you the answer infinity in case the base guy, the b, in the case of b raised to the power x, this guy is any number greater than 1. if this number is between 0 and 1. I told you there is only two possibilities out of three. Negative we have ruled out. Only two cases, either it can be in between 0 and 1 or it can be greater than 1. If the guy is in between 0 and 1, then limit x approaching infinity b raised to the power x will always be, the answer will be 0, and limit x approaching minus infinity b raised to the power x, the answer will be plus infinity. So these are the rules which you already know in different form. Maybe you don't remember them in this form, but you already know when you apply the limits, you already know that if something is written and when you apply the limit infinity on something like e raised to the power minus x, and you know that when you apply the limit x approaching infinity e raised to the power minus infinity, you always get the answer 0. So you already know some things about the best exponential function. We just write them into the simple exponential function. So all the exponential functions follow the same rules which are the followed by the best exponential function. You know all these rules for this guy. You have done these limit problems in chapter 1 or 2 maybe in the advanced mathematics 1, and there you were doing all those things for this guy which is the best. But the rules are same for all the exponential functions which you already know. So for example, if you are asked to find the limit x approaching infinity 2 raised to the power minus x minus 1, this is a function. The function f of x is equal to some function g of x minus 1, and this g of x is what? G of x is the guy b raised to the power x, and b is what? B is 2 and the x is minus x. So you can always have a composition of the two functions. So this function is very much similar to the exponential function because it involves the exponential factor. So now if you want to apply this limit on this guy, you can write it as, you already know directly, because you already know that when you put negative infinity into the exponential function, it gives you 0. In place of 2, if you have e, you already know that if you have e raised to the power minus x and the x is approaching to infinity, then the answer is always 0. You have done these questions in chapter 2. So here we are going to see why it is 0. Suppose now instead of e we have the simple, this is not the best guy, this is not the best exponential function, this one was the best, but the rules I told you have the same. So to this function I can write limit x approaching infinity. Let me write this as 1 divided by 2 and whole raised to the power x. So I can write this or not? Can I write this?
Yes, of course.
Yes, sir.
It should not be like this. It should not be like this.
It should be. It should be.
Is it right or is this right?
The second one.
This one is right?
Yes.
What is wrong in
Second one
this?
is right.
What is wrong in this?
Now it's
Okay, if I write this guy as 1 raised to the power x, and if I pick up the same power from both, it becomes 1 over x, 1 by 2 raised to the power x. And this is the same like this.
okay.
You know 1 raised to the power anything is always 1.
One.
Yes,
So
sir.
you can write 1 as 1 raised to the power x. So
Okay.
both are correct. Anyways,
Yeah.
now look, this function is the exponential function, the stupid guy b raised to the power x. But in this case, the b is 1 by 2, and 1 by 2 is less than 1 and it is greater than 0. And this is just another function which is added to the exponential function. So the problem is in the exponential function. And so I have seen that the guy b is in this interval, and just before we have written the rule that if the b is between 0 and 1, then limit x approaching positive infinity b raised to the power x will always be 0. So it means when you put this limit inside, this guy according to this rule will become 0, and this is minus 1. It has nothing to do with the limit, so the answer is minus 1.
Minus 1.
So now you see, when instead of this, if you have the function which you have already solved in chapter maybe 1, 2, I don't remember, and you have this kind of question there, limit x approaching positive infinity, e raised to the power minus x minus 1, and you directly plugged in the limit and you told me that this is equal to 0 minus 1, this is equal to minus 1. Remember? It was not me, maybe Dr. Thelma, but I'm sure you have solved this kind of limits, very basic limits. And in those limits, you always tell me that when exponential function has raised to the power negative x and the limit is approaching to the positive infinity, the answer for this is 0. But you never know why this is 0. So this is 0 because of this rule. Because the exponential function is always greater than 0. It is never less than 0. And we have already defined the two rules for the exponential functions. So these rules are valid for all exponential functions. And out of those exponential functions, e is the best exponential function.